Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this second lecture of module 11 on geomorphology of sea, seashore, shoreline and shoreline engineering geology, hazards and mitigations. In previous lectures we have discussed about some basic aspects related to ocean, different agents which are going to modify the coastal area due to erosion and deposition. In this lecture, we are going to elaborate about the wave propagation and concept of surf zone as well as breaking of waves and associated parameters. In these lectures, we are going to highlight about the wave propagation and concept of surf zone as well as breaking of wave. Regarding this, we are going to cover about introduction related to waves and the types of waves, surf zone and principal parameters affecting the propagation of waves. Friends, as you know, the wave action is surely a principal factor in modification of seashore or coastal area, particularly geomorphology. However, waves generated by the wind blowing over the sea surface is a principal factors regarding the generation of waves. The wind blown induced generation of waves are not of the same height and period, and their heights and direction changes with respect to their direction of travel as well as depth of water. In shallow water, the parameters concerned to attributes of wave changes pronouncedly in comparison to the change in their parameter concerned to the deep water location. Hence, the wave changes their parameters when travel from deep water to shallow water toward the seashore or coastal area, causes various type of erosional activity at different locations close to seashores and away from seashore. In shallow water, the property of wave change and they change height and their direction of travel, which must be considered during the design and calculation or estimation of the wave impact on the shore area. However, waves generated by the wind blowing over the ocean surface, as we have already discussed, is of not same height and period, and they are recognized as random waves. Here, concerned to generation of waves, we are going to see in this figure, when the wind started flowing over the sea water, then the pressure inside the wind body is going to push the sea wave, sea surface, and due to pressure difference imposed by wind on the surface of sea, there is a generation of ripples. there is a generation of ripples, and these ripples are propagate in form of waves toward the shore area. As per description of this cartoon, we can say that the waves generated by the wind blowing over the ocean have a range of wave period or wave frequency and are clearly not of the same height throughout the propagation. You can see here the wave height is different, but here the wave height is different, again the wave height is different. Similarly, if the wave propagate here, then this is different. The wind generated wave is the mechanical process of wave generation induced by wind are complicated due to turbulence fluctuations due to the turbulent fluctuations in the wind. The turbulence fluctuations in wind cause pressure fluctuations in wind, and the import such pressure fluctuation on surface water of sea during the wind and sea water interaction results pressure fluctuations which deforms in form of ripples, and these ripples propagate as function of the pressure fluctuations, and as a result there is a continuous transfer of energy from wind to water. This is the story behind the generation of waves in seawater. This process commonly results in ripples traveling at an angle to the main wind direction, giving a diamond-shaped pattern to the water surface, and such induced effect come in form of waves. As the ripple grows, they begins to deform the airflow above them, and this causes a change in the pressure distribution on the water surface, and the rate of wave growth increases rapidly. The airflow and the wave height continue to increase, and the speed of waves increases along with the height and the length of waves. In such way, the wave propagates from one point to another point, and the wave travels at the same speed as the wind, and thereafter there is no transfer of energy after the wind to the water when water attains the speed of wind. Initially, the speed of wind were found more in comparison to the speed of ripples or speed of waves. When waves reach the speed equal to the speed of wind, then there is no energy transfer from the wind to the water. Based on non-linear wave theory, it is possible for the energy to be transferred between the waves, which allows longer waves to grow further by addition of energy from the shorter and slower waves due to superposition. In this way, there is a formation of oceanic waves in seawater. Here, as the generation of waves depends on the pressure fluctuations present in wind, the wind frequently changes the direction as well as the magnitude of the pressure with respect to time. Therefore, it is very difficult to predict the generation of waves and behavior of waves and associated parameter correctly. If we are going to see the generated waves by wind blown, the waves can be classified in two categories: linear waves and random waves. Linear waves are uniform in nature. However, the name indicates there is uniform distribution of the pressure, resulting in linear type of waves. However, the random waves are asymmetrical in nature, and it is generally formed in water of limited extension. Here, for our future discussions coming in this class, we have to know about general concept of different parameters we are going to utilize in this class as well as in our future class. In general convention, when we are going to see any waves, simple wave, this is the still water or reference point. This topmost part in upper above this reference line is known as crest, as we have already discussed. The bottom point below this reference level is known as trough. The height of the waves from the crest, line drawn from the crest to the reference line, is known as amplitude, and the height from the crest up to trough is known as height. This distance is recognized as height of waves. The linear length between two crests is recognized as wavelength, and if there is a generation of more waves than the gaps of the time, we are recognizing as the phase gap, and associated various parameters. So one by one we are going to elaborate here for easy understanding related to our future steps. Wave frequency is the number of waves that pass a fixed point in a given amount of time or given time gap is recognized as wave frequency. Generally, wave frequency is measured by counting the number of crests of the waves that pass the fixed point in 1 second or in 1 minute or in 1 hour. The time scale depending on the nature of works. The wave period, the time it takes for two successive crests to pass a specified point is known as time period. This time period and wave frequency as well as wave length have some relationships we will discuss. The wave number is the spatial frequency of wave over a specific unit distance, and it is measured either in cycle per unit distance or in radian per unit distance. A wave number is related to but not different from frequency. A wave number is related to frequency but different from the frequency, which is a temporal in nature. The wave amplitude, as we have already discussed, the maximum distance the particle of the medium moves from their resting position when a wave passes through a medium during its travel. Wave height is the vertical distance between the crest and trough of wave, and the wavelength is the distance between two crests, two consecutive crests. Then another parameters we will utilize wave celerities, and the wave celerity is the speed at which an individual wave advance is called as wave celerity. The wave celerity may be generated due to wave swelling and the change in shape and behavior of waves. Advance into water of decreasing depth is recognized as wave swelling. The wave swelling indirectly results from breaking of waves in a particular zone recognized as surf zone, and the surf zone or breaker zone is the zone where waves breaks as consequent of depth limitation. Here, in view of the breaking of waves and consideration regarding the surf zone, we have two specific zones related to the movement of waves. In the zone of breaking of waves, the vast zone forms the land-ocean boundary at the landward edge of the surf zone. The water in surf zone is shallow, usually between 5 to 10 meter in depth, and the backwash zone is the backwash where this zone is located towards the offshore direction, where the waves are moving toward the deep ocean side, is recognized as backwash zone. Simple wash zone is a zone from the land ocean boundary and the wave moves toward the shallower or land side. The deep water and shallow water, we can consider the deep water is generally defined as a depth at which the light begins to dwindle, and typically it is close to 200 meter depth maximum. The deep water is generally defined as the depth at which light begins to dwindle, and this depth is generally more than 200 meter. However, the shallow water we are considering as a marginal or inland extension of ocean with average depth of less than 200 meters. The maximum limit of the shallow water is up to 200 meters deep only. And it is also called as coastal or neritic water zone. In between the deep water and shallow water zone, there is a transition lying between deep water and shallow water as transition water zone. Friends, if we are going to see some mathematical specification regarding linear waves or uniform waves following the linear wave theory, the linear wave theory is a solution of a simple Laplace equation. Second derivatives of phi with respect to second derivative of x plus second derivative of phi with respect to second derivative of y. Here this is applicable for a wave elevated from the normal surface x. This part we have already discussed. It is recognized as crest, and this part is a trough. This is the reference line or still water level. This portion above we are considering positive. In this way, the direction of propagation of wave is toward this x plus direction. So here x is a plus, here y is a plus, here y is a minus, here x is minus. So y is equal to 0. There is no generation of waves, means no wind present. After interaction of the sea water with wind, there is a generation of ripples having this crest and trough and started propagating towards the coastal side or shore side. The solution related to this equation involves certain parameters which we can see here. The parameters eta xt, the free surface at time t is equal to 0, where the u and x are the velocity components in x and y direction, here in v, here is u, and then phi xyt is equal to two-dimensional velocity potential, where this rho is representing the density of water, g is acceleration due to gravity, where this amplitude a is a half of this h, here this value is h. As per linear wave theory, as we have discussed with respect to previous diagram, the k is a wave name, the k is a wave number which is equal to 2 pi by L, where L we are considering as wavelength, and the wavelength is the distance between two consecutive crests of a wave. The omega is a wave frequency which is equal to 2 pi by time period, where the t is a wave period or time period of a wave, and the d we are considering as water depth, and specific for shallow water we are utilizing some prefix here. For deep water also prefix, some transition water also prefix, and the celerity of waves we are recognizing with the letter C, which is simply wavelength by time period. With help of these we are able to determine celerity. If we know the wavelength and the time period, we are able to determine wave frequency in a radiance or in general condition with help of this 2 pi by t, and wave number 2 pi by L, where the L is a wavelength, in our future discussions. First we are going to elaborate about the parameters which are going to affect the wave property. The major parameter which are going to influence the generation of waves are speed of waves. It is also recognized as a knot when specified at 10 meter above the water or ground surface. Then another important, first parameter is speed, second parameter is a fletch length. Fletch length generally we measure in meter, but in traditional oceanographic concept or the sea science concept, we are utilizing nautical miles, and 1 nautical miles is equal to 1852 meter extension. Then third point is a duration, TD, in hours or in second or in minute, depending on the nature of work. The fletch length, it is the horizontal distance over which the wave generating wind blow. You can see during the storm there is a generation of winds with different pressures. The difference in pressure or fluctuation in pressure in storm assisted wind is going to impose pressure on the seawater. The energy present in wind progressively imposing on this are going to transfer in water, and due to transfer of energy from wind to water, there is a generation of ripples. The continuous transfer and addition of energy from the wind to the water is going to enhance the height and wavelength of the waves in direction of propagation. Initially, the transfer of energy from the wind to the water of sea is not in proportion. More pressure is present in wind, which are not able to activate the pressure in seawater. Therefore, initially the energy transfer from the wind to the sea is more. However, when the sea waves reaches the energy level equal to the energy present in wind, then there is no transfer. Means there is a setup of equilibrium condition. In this way, the waves are propagating toward the shallow side, and the effective distance up to which there is effect of wind over the water is recognized as fletch length. This concept of fletch length also we are utilizing in case of reservoir formed due to construction of dam in any huge water body. The increasing fetch length results increase in height of waves. However, this increasing activity of height is limited to the fetch length up to a 1600 kilometer only. It is important to consider the wave height unable to enhance beyond this maximum fletch distance, that is the 1600 kilometer. The waves in shallow water, when the waves moves from deep water, here you can see deep water, the waves started moving from deep water toward the shallow water. The various conditions, barriers and features present in shallow water zone is going to influence the shape and behavior of waves which are coming from deep ocean side or seaside. So the condition at a shallow water side are influenced strongly by shallow water wave process, and the features present in shallow zone is going to control the shape and behavior of waves on one side. On another side, the generation of waves is going to modify about this shore side. The features present in this zone is going to control the behavior and shape of waves. However, these waves interacting with this zone is going to modify the features of this shore zone. There are several physical processes that takes place as waves travels into shallow water from deep water. There is shoaling, refraction, frictional dragging, and percolation, diffraction observed at the points where this wave is filling any barrier, like here sandbar. You can see when the waves is going to interact with the sandbar, then there is a changes due to wave shoaling, due to refraction of wave, due to frictional resistance offered between the surface and the surface of waves. These actions going to result ultimately the wave breaking at the outer limb of the surf zone. Then what is the surf zone? A surf zone is as the sea surface waves approach shore, they get bigger and break, forming the foaming and bubble containing surfaces called as surf zone. So we can see here the wave breaking, and this type of zone we are going to recognize as surf zone. The surf zone generally associated with the beach area. Due to breaking, the waves is reduced in height. You can see the waves is reduced in height, and they continue to move in and they run up on the sloping front of the beach, forming an uprush of the water called as swash zone, and the water then run back toward this zone is recognized as backwash. And the near shore zone where the wave water come onto the beach is also considered as the surf zone, as we have already discussed, and the water in surf zone is shallow, usually lying between 5 to 10 meter depth. This causes the waves to become unstable and form the returning waves which are going to move toward the offshore side or toward the deep ocean side on one side, and some branch going to move on the forward side. Friends, this lectures I have prepared with help of a material written by Holmes P. in 2001 on coastal infrastructure design, construction and maintenance, an EDP course. Then partial supports from the material taken from the Gangopadhyay S. in his written book Engineering Geology, published from the Oxford University publication, and partial supports from Engineering Geology book written by Well F.G. in 2007, and then textbook of Engineering Geology written by Kashabulu N.C. in 2016. Friends, in these lectures we have discussed about some elementary concept related to types of wave and concept of wave, how the wave is generating in sea waves, and the waves are formed due to pressure imposed on seawater from wind. In general, the waves are categorized in two categories: linear waves or uniform waves and random waves, and the surf zone is the points where the waves are breaked. The celerity is the relative movement of waves, because the waves on the surface is moving with more velocity, but the waves below the water is moving with the slow velocity. This relative type of distorted movement of wave is known as celerity. and the change in shape and behavior as the wave advances toward the shallow water from deep water is known as swelling of waves. Dear friends, in this class we have elaborated about wave, concept of surf zone, wave swelling, about backwash, about wash zone, and the role of wind in generation of waves and transfer of pressure from wind to seawater. Thank you very much for your patience hearing.